So this is a flipbook of our high-res simulation of our shot. And you can see that there is a lot of detail. There's a lot going around in the simulation. There is a lot of droplets, there is a lot of dynamic behavior, there's a lot of collisions from a cliff, and then there is a lot of dripping behavior from the cliff as well. So you can see that our collisions here are working perfectly. So what is the value that I ended up using on my ocean source particle separation? Well, that was 0.098. So that would give us from 996,000 points to roundabout. Now that's going to take a little bit of time because it's going to calculate all that data, and then it's going to subtract our collisions from the cliff as well. So it will take some time to compute. The more the points, but the more computing Houdini has to do. Right, so we have 8 million points here, and that's not too much, but for this sim it works perfectly. Don't forget the fact that we're using narrowband, so as soon as our spaceship is going to hit underneath here in the empty space, it's going to create a lot more points. Right, now how can I take my points from inside the DOP.NET and call it outside into the SOP level or at the SOP level so we can start caching it out? Well, for that we need a node called DOP import fields. And what I'd like to do is I'd like to select these two, press C and color them both green so I can, recognize them from far. And in the DOP import field, we need to specify the DOP network, which is going to be our DOP.NET. So with this being selected, what I can do is I can grab and hold and drag that onto my DOP network. And for the DOP node, what we need is the flip object. So essentially, if I put this to manual, essentially that flip object right there. So I can just say /flip object. There you go. And then obviously we have to specify that what we're going to importing from the DOP.NET into the SOP level. So from the presets menu, just choose flip fluid, and that would call in the geometry. That's going to be our points, the surface field, and the vel field. The surface and the vel field, they are needed because we need to use those to simulate our white water in the next chapter. Right, so if I visualize this, I'm going to put this back down to 0.25. Right, I'm going to put this back to auto update, and you would see that we have our points here. Now I can say hide other objects. All right, so our points are here now, and obviously we can just put down a file cache SOP and just start saving those points. So let's say flip points. But there is a trick. There is a trick to compress all that data before we save out our points in our file cache node. And that trick is a node called fluid compress. Now fluid compress would essentially pack our geometry into these weird looking volumes, and that would save us a lot of disk space. So all you have to do is make sure that particle separation on our ocean source node is matching exactly the particle separation on our fluid compress node. Paste relative references, and that's it. Leave everything be. Don't worry about how it looks. Obviously when you give this a lot more resolution, i.e. 0.98, so again that's going to take some time to compute, and that's how it looks. Now what we can do is we can say flip points and then say the same exact strings that we were using to save out our ship and ship geometry or our cliff geometry. So it's going to be $hip. So it's going to look for where this hip file is saved, and then in the geometry folder it's going to create that folder, and then $os, right, / and essentially not and dollar, and essentially $os is a variable that returns the name of the node. So what it's going to do is it's going to look for where this hip file is saved, and then it's going to create a folder called geo as long as the create intermediate directories is switched on here. and $OS is going to create a folder called flip points, and then it's going to create the BGO flip points $F, which is the number of the frame, 1.bgo.sc, which is the compression of our BGO. And if we say load from disk, it's going to load our data from the disk because I've already gone out and saved our simulation. Okay, so now if let's say if I go frame 97, it's going to read from the disk, and you would see what I mean when I say that these weird volumes, there you go. So it's not points, these are volumes. But how do I visualize this? Like, obviously I need to mesh these out. I need the points for the whitewater. So how do I convert it back to points after I save it out as in a compressed format? Simple. Just put down an unpack node and you would be able to visualize the points. There you go. Easy as that. But here's my question. You can see that it looks blue and there is a lot of detail to it between blue and white. So how do I make my points look like that post sim? Because it was looking like that when we were doing flipbooks beforehand, because under the flip object, under the particles tab, there is this gradient here, which is essentially dependent on the speed and the attribute V. So we can recreate that at the SOP level. That's not a problem at all. So I'm just going to drop down an attribute VOP node and auto update that so we can see our points. And what I'm going to do is I'm going to take the V attribute, which is a vector at the minute, and put a length VOP node here. And that's going to convert our vector into a float value. Now, obviously, when it outputs the float value, we can play around with it. And then I'm going to drop down a fit range. So I need to fit the source min and the source max, so promote parameter, and that's going to show up here on the top. And then I'm going to connect the output of my fit, not that, but a ramp parameter. Right. And then the output of my ramp goes to CD, which is the color attribute in Houdini. And you would see that we already have a black and white value, black and white visualization of our flip points. Now all we have to do is change these colors, right, that one. And then in the 0 to 1, in the maximum value, I'm going to put a value of, let's say, 11. Easy. That's all it takes to create a visualization manually. Just as simple as that. Right. And then I'm going to say out flip points. Now, before I conclude this chapter, I would like to talk about just one very important thing, which is inside the .NET under the flip object, if you go to the creation tab, there is this allow caching that is switched on by default. Now, when you play in your viewport or in your Houdini scene, when you play your timeline, allow caching caches all those frames out. But obviously, it also uses a lot more RAM. So before you start caching these out, when you click on save to disk, before you want to cache that out, I would advise to turn that off, because Houdini would use a lot less RAM when it comes to saving out the data and computing all the flip fluids. So that's a very handy trick. Just switch that off. It works for pyro, it works for fluids, it works for essentially any sort of dynamics. All right. Okay. So this concludes chapter 1. And in the next chapter, let's take a look on how we can take these points and simulate white water.